Hello, I am Mahi, and today I'll be presenting our new technique for skill learning in a changing world. In this work, I will be presenting Discovering Incremental Skills, or DISC, an unsupervised skill learning algorithm that can learn skills adaptively with changes in the environment or agent dynamics. In behavioral learning, we often assume that the agent and its interaction with the world are static. However, this assumption often falls short of reality. Agent may face slow, continuous changes or fast, discrete changes in both their environments and their internal dynamics. Environment changes can be slow, like day-night cycles, or fast, like opening a door in the environment that leads to an entirely new setting. Similarly, an agent sensor can be slowly drifting out of calibration, or the agent can break apart. Let's take unsupervised skill discovery algorithm as an example. Here, the goal is to learn distinct behaviors or skills conditioned by a latent variable z. Generally, these algorithms learn all the skills simultaneously, and while they usually learn good skills under static environment and agent dynamics, they tend to overfit to a single setting of the environment and the agent, and often fail to adapt when the environment or agent dynamic changes. To learn skills in a changing world, we take our goals from continual and lifelong learning literature. In particular, we look for algorithms that can learn new skills to adapt to changed situations, but at the same time, we try to make sure that the skills we have already are not forgotten with changes in the environment or agent dynamics. This is why we present DISC, which is an incremental skill learning algorithm consisting of both of these properties. DISC can learn an arbitrary number of skills incrementally. At any given time, given policies 1 through n for each skill, it learns a new policy for skill n plus 1 by optimizing for diversity and consistency in the new skill. Let's see how it works in practice. First, given the previous skill policies, DISC tries to maximize the diversity over the trajectories generated by the new skill policies against all the trajectories generated by the earlier skill policies. Next, the consistency penalty is added, and it forces the generated trajectories to be consistent with each other. This gives us a new skill policy which behaves differently from the previous skills while still being consistent. By optimizing for diversity and consistency, we can train an arbitrary number of skills with DISC. We ran some experiments to see the effectiveness of DISC under changing environment and agent dynamics. In our first experiment, we used DISC to learn skills in an environment where the blocks restricting movement disappear over the agent's lifetime. In our second set of experiments, we learned skills with a modified ant-agent whose legs cyclically break and recover over the agent's lifetime. In the block environment, we observed traditional skill learning algorithms latch onto one particular instance of the changing environment and ignore further changes. On the other hand, DISC takes advantage of the newly available parts of the environment as it learns its skills, and it learns a diverse set of skills, most of which were not available in earlier episodes. Here, we can see the set of full results over 3 different instances of the block environment. We can see that DISC performs much better compared to the previous skill learning algorithms in this changing environment. On the breaking leg environment, DISC trains and updates only one skill at a time while keeping the older skills frozen. Thus, each skill in DISC can focus on a particular broken leg over the lifetime. Traditional skill learning methods, on the other hand, keep updating all of their skills at all times. This behavior leads traditional skill learning methods to overfit to the latest environment and agent setting, while the DISC agent retains significant performance at all instances it has been trained on, including those it has not seen recently. Here we can see the performance of the skill library trained by DISC and in traditional skill learning method. Even beyond these changing environments and agent dynamics, DISC performs well in standard static settings. Here, we show the trajectories resulting from agents trained by other state-of-the-art unsupervised skill learning algorithms compared with DISC, where each algorithm is trained for the same number of environment steps for each of the environments that we see here. Skills learned by DISC are generally equal or has better performance compared to the previous algorithms. The skills learned by DISC can also be effectively used in a hierarchical RL setting, where it performs much better than previous algorithms and also a baseline of not using hierarchical reinforcement learning at all. This is our algorithm, Discovery of Incremental Skills, or DISC, and you can find our paper, open source code, and more videos on the link presented here. Thank you.